Tonight's blood moon completely changes everything we thought we knew about the universe. You can see behind me the Earth's shadow starting to creep over the moon in what will soon be a total lunar eclipse. When the moon moves completely into Earth's shadow, it will not go black. We will still be able to see it, and it will appear with a reddish hue, hence the name blood moon. And the explanation of this observable, repeated phenomenon disproves Einstein's relativity, disproves our current standard model of quantum mechanics. Applied science stays the same. The what we're very good at. The why we have completely wrong. Let's start with relativity. Relativity says that light moves between observers. Here I have A and B, the sun and the moon. That light moves between observers at the same speed all the time. In order for the quantum mechanics equations to hold good and energy calculations to hold good, that speed needs to be equal to c. So in order for you to have a speed, you need to have a definite path, because speed is the rate of change over time. So at every point along that photon's path, it's moving at c always. That's required for these theories to be true. But in order for the explanation of our phenomenon to hold good, light needs to have different speeds in different mediums. Even deeper than that, different frequencies of light, different colors of light have different speeds within the same medium. When we look at my beautiful drawing of tonight's eclipse, we know light from the sun is still getting to the moon. Relativity and the warping of space-time is not enough to explain how light can make it from here to here. We introduce a concept called Rayleigh scattering in the atmosphere. And we say that that is what allows the light to get here. But what is Rayleigh scattering? Rayleigh scattering is what we say when we say white light. So a packet of white light has all different frequencies in it, and then those frequencies scatter throughout the medium. That doesn't make any sense. You can't have this one thing have multiple frequencies. It has one frequency, and then something else has other frequencies. The trail of the wave will have different frequencies. The wave will be stretched out behind it. But this completely steps on wave-particle duality, because you need to have different speeds of light and in order to determine the refractive index, to measure the different speeds, we've used the one-way speed of light. So we've measured light going one direction. We said, okay, light here, we know how much time, we know how fast it was going, observations match, that's all good. You can't do that in relativity. You can't have two clocks that are simultaneous. It completely defeats the theory. You cannot measure the one-way speed of light in relativity. So if you've used the one-way speed of light to explain these observable repeated phenomenon, you've disproved relativity. If you've disproved relativity, you've disproved quantum mechanics. They're wrong. They need to come out of the textbooks. It's all about maintaining this illusion of empty space. But just like everywhere else, it's one of those things that's so obvious, the professionals are going to refuse to look at it. The blood moon completely disproves Einstein's relativity. It completely disproves wave-particle duality. It proves wave behavior. It proves light to be a wave. It proves optical theory. It proves applied science. It disproves the theoretical nonsense that we can't confirm. This is a macro observation from space. We're talking about light from the sun getting to the moon, and we can't explain it with relativity. We use relativity to explain GPS satellites that are barely, you wouldn't even be able to draw a line how close they are. But we can't use relativity to explain how light makes it to the moon. And what kind of light makes it to the moon specifically? Red light. Why is the sky blue? Dispersion. Okay, cool. Dispersion of a wave packet happens in sound. Dispersion of a wave packet happens in water. Dispersion of a wave packet is classical wave behavior. There is nothing particle about it. What you have is an interaction with matter. And in order for dispersion to occur, the different frequencies of light need to have different speeds in the same medium. Then light's not moving relative. That's light. It's not moving relative at the same speed. We just say it's in a different medium to make up some extra layers of nonsense. But how is it not in a medium before when it enters water versus space? It's just more condensed matter. There's matter in space. It's just super spread out. So we're just talking about a more condensed version, a different version of it. There's still a medium. This is such a nonsensical argument. For relativity is all about the speed of light relative to observers. When you go to calculate the speed of the light traveling from the sun to the moon, if we ignore the Earth and we just say, what's this light doing? We're saying it's moving at a constant speed, but we can't explain how we see red light bounce off the moon in this framework. You have to introduce the micro level dispersion to be able to prove it, but you're using micro level calculations to explain a macro phenomenon. The macro should be able to explain the micro, and it's not. When light splits, again, this is all classical wave behavior. In the double slit, there is nothing but wave and wave interference pattern. The probabilities govern wave interference patterns until the photon contacts matter and is absorbed in a discrete packet, until the wave contacts an atom and is absorbed into that atom in a discrete packet, which is just a preset human limit of where we're going to call the photon, how we're going to make it a unit. It's a mathematical unit. The photon didn't exist in 1905 in special relativity. Photon didn't exist in 1915 in general relativity. Photon didn't exist in 1919 during the Eddington event. The photon was first coined in 1926, and when it was first coined, it was used as a mathematical term, as a tool, not as a real thing like tensors in general relativity. And they're mathematical representations and symbols we can use to better explain the phenomenon. But for light, for the same light, if I have red, I have blue, I have green. Relative to the observers, they're moving at different speeds. I don't think the significance of what I'm presenting regarding the lunar eclipse is quite landing. So even though I'm not feeling that well, I'm going to try again here, because for my time is an illusion, folks, this is the proof. For my gravity isn't real, folks, this is the proof. For my Einstein was a plant, this is the proof. Relativity was proven with a solar eclipse, and it will be disproven with a lunar eclipse. Again, the fundamental underlying assumption is that light moves relative to observers, which is disproven with light getting to the moon during a lunar eclipse, red light specifically. So if we are an observer on the moon, is that light moving relative to us at the same speed the whole time? No, it's not. And we can laugh and we can scoff at the truth, but God gave us rainbows. And what do rainbows prove? Rainbows prove that light has different speeds in different mediums. So different frequencies of light move at different speeds in the atmosphere. Red, blue, green, none of them are moving at c in the atmosphere. Yet all of our proofs of relativity come in the atmosphere. Our first hard evidence for particle physics being muon decay in the atmosphere. If light's not moving relative, time's not moving relative. Now our GPS satellites also in atmosphere, we're taking measurements here. The math is good, okay? The logic is nonsense. What we're doing is perceive changes in time. We measure time using light and the frequency of light from a cesium-133. So we're describing mathematically what happens, but logically, nonsense. Time travel, quantum this, alternate timelines, science fiction, and your own eyes prove it. You're saying the words without realizing what they mean. This is where everybody gets relativity wrong. You're thinking about it through a common sense lens. You're thinking that it just means that light in a vacuum has a constant speed, but relative to what, okay? In a logical, just common sense framework, which I'm gonna assume that's where you're at here, you're thinking about it as a ground speed, kind of like a car driving through that vacuum tube at the same speed, okay? That it's a physical thing, but that's not what relativity says. Relativity says that light moves relative to observers at the same speed, no matter how fast they're moving. So if this was like a car in here driving back and forth in this vacuum tube, right? If the car is coming at me at 60 miles an hour, and then I'm going at the car at 40, then we're gonna have 100 in between, right? But not with light. It's just always the same speed. And it's like, what? It's very hard to conceptualize because that's what we allow time and distance and all these other things that we can't prove to move. Again, the proof was with muon decay in the 1940s, and muon decay was in the atmosphere. And when we're talking about in the atmosphere, we're talking about rainbows and photons and dispersion and Rayleigh scattering and how all this relates back to relativity, right? Because again, light gets to the moon during the lunar eclipse and space-time bending cannot explain it. So we know that the refraction occurs in the atmosphere. And in that refraction, we've measured that those frequencies of light have different speeds in the atmosphere. Red has a different speed, blue has a different, green has a different speed. But what do we say for the photon? We still say that the photon for all of those is moving at c. So even though the light waves are each moving at different speeds with different frequencies, that the photon, why? For all, it doesn't make any sense, okay? Again, we're thinking relative to the medium. That's cool. That jives. But when you talk about why we even keep light speed around like that, why it's such an argued thing, it's because in Planck's constant, light speed is factored in. So when you talk about the energy of a photon and how it's calculated, you have to take the frequency of the wave. You can't know that you need to measure the frequency. In order to measure the frequency of a wave, you need a time period. You can't just take a snapshot. You have to have at least one full oscillation of that wave, which is going to come at different speeds for your different frequencies and all that, which jives. And that's how the math is done in practice. It's just the explanation of time moving as an actual dimension opposed to it being perceived. Okay, this is what the whole argument comes down to, is whether things are real or not. All right, Nobel Prizes have been won for virtual this and that because light doesn't have a medium. And I'm going to keep digging at this one. I don't have a good explanation yet, but it always comes down to heat versus light, and that light gets expressed as heat. But heat is mechanical motion. Heat is the movement of molecules, and when you isolate an atom, there is no heat. You need movement for there to be heat. So we have a non-physical wave, make a non-mechanical wave, producing mechanical movement. And the cycle's broken in there. I'm gonna keep digging, but it's relative to the medium. Perceived changes. When we say photons are always traveling at the same speed, what do we mean? How does that shake out? How do we know that? Is that true? Is that not? No, it's garbage, and it's absolutely not true. It's very clear it's not true. So when we talk about photons, we talk about their energy. It's all based on the frequency, okay? In order to establish frequency, you have to measure at least one full oscillation of the wave, okay? In order to get one full oscillation of that wave, you have to have a time period. This wave moving over a time period through a spatial dimension, this occupies space, right? But when we measure a photon, where are we measuring it? We're measuring it at a point. The photon takes up a point in space, and it's just the energy that passes the point in units. And then the bigger the amplitude of the wave, the brighter the light, the more photons we just stack on top of each other. Like, it's really clear that photons are a fugazi, a whoozawatzi. They're just for doing the math. They're units, decibels, not the same as decibels, but you get what I'm saying? They're not physical. Light is a wave. Very good, Grasshopper, but you say light is the wave and photon is observation. Photon is measurement, and measurement problem, observation problem are problems of the imagination. Imagination's gone wild. The photon is an inch, and in thinking you could give an inch, we've allowed them to take a mile. An inch actually is a really good comparison for a photon. I was being silly in the delivery, but is an inch real? Can you give an inch? Not by itself. It's a description of something. It's a quantization of length, but you can quantize the length in many different ways. Is 3 feet correct, or is 1 yard correct? They both are, and neither of them are real. Yards, inches, feet, they're not real by themselves. You see, they don't exist independently, just like the photon doesn't exist independently. It's a quantization, a representation of the wave. And you think it's a meaningless distinction, but it's super important, because these ideas of parallel reality and time travel and all this all come from this logic and this mistake, where we have the photon representing a physical object rather than a mathematical unit. And when you make that correction, the world makes a whole lot more sense. You need the wave, but a wave of what? It's the same thing. You can't have waves in the ocean without the water. You can't have light travel trillions of light years without a medium, without a carrier for the wave. And that wave is not moving relative to observers. It's moving relative to that medium through space. And we consider that relative still adjacent to observers, that the medium close to observers is not moving, and that's why relativity works. But this is why everybody's going crazy, because we've got these terrible definitions of the universe that people are taking too seriously and not listening to the weirdo yelling at the train stop. 1 × 1 = 2. Terrence Howard's appearance on the Rogan show with Eric Weinstein was a huge moment for me. There's a point in the show where Weinstein turns to Howard and says something along the lines of, you're challenging the language here. This is a study of the language. And I go, oh, he's not trying to say that mathematically the product of 1 and 1 is not 1. He's challenging what multiplication represents. He's challenging the underlying fundamental assumptions of the variables themselves. How can you multiply something and not get more somethings. To multiply that's what he's saying, but nobody listens to that. That's too complicated for people. So you got to shout something ridiculous like 1 times 1 equals 2 to be able to have a conversation about it.
All right, we're doing the golden ratio fine. I started this one by request, but it was a massive learning experience for me. So thank you, and buckle up because we're going to take it through everything. We're going to do sacred geometry, the Abrahamic religion, space force, space relativity. So here we go. What is phi? Phi is a linear association, a linear approximation of the rate of change of the Fibonacci sequence. And the Fibonacci sequence is taking each successive number and adding it to itself repeatedly. So you take 1 plus 2 equals 3, 3 plus 2 equals 5, 5 plus 3 equals 8, and you keep going up. Now, when you take the average difference between the two numbers and you map that, you get the golden ratio. 1.618 is the approximation, but just like all the good numbers, it's an irrational number, meaning the decimals go on infinitively. You never actually get the exact calculation. You could just keep going forever. And that's an important thing because all of these represent a non-linear reality with our closest approximation being linear, but that's an important distinction. Now, where do we see phi? We see it in nature everywhere. We see it in sunflowers. We see it in hurricanes. We see it in growth specifically. We don't see it in construction. We don't see it in built structures. It's not a strong geometric shape that is produced from using this ratio, but you do see it with growth and a balance, harmony of growth where the pieces remain in balance with the whole. And now let's start breaking that down more, okay? Because what shape do we get geometrically when we represent phi? We get a pentagon. And inside of that pentagon, you can fit a pentagram, a 5-pointed star. Now, inside of that pentagram is the golden triangle, an isosceles triangle, where 2 of the arms are the same size, and then the shorter one is not. Now, there's an important relationship here because if you represent the short side by x, the long sides would both equal x times phi, okay? That's the ratio that remains within the golden triangle as it scales. Now, also important thing here, the angles of the golden triangle are 36, 36, 72. If you take each of those numbers and sum them, you get 999, okay? So somebody made fun of my drawings the other day. I don't really care. I'm done making it fancy. I'm dropping knowledge bombs on here. You can deal with it. So you get the Space Force logo from the golden triangle, from the relationship of phi, which represents growth, okay? But oh wait, before we do that one too, let's also do circular phi, because what do we get when we represent overlaid circles where the radius are a function of phi? You get, it's a terrible drawing, but you get a crescent moon. So overlapping circles with radius of phi gives you, with radius like in relation to each other, a phi gives you a crescent moon. So in Starry Night, in many crescent moon, it's phi is the relationship between those to map it out for artists. Now, so we have growth, we have a balance of circles, and then what do we have when we need structure? What's the strongest structure that we know of? The hexagon. So when you need growth, you have the pentagram, 999. And when you want to invert that growth, what do you get? You feel me? Okay. Now for sacred geometry, again, because this represents growth in relation to the whole. This is how populations should grow in comfortability. It does follow an exponential growth, but what you have is a balance of constraints and availability. What was the last part that I wanted to finish up on that? Where you don't see phi is just as important as where you do. You don't see phi on the micro. You don't see it at the atomic level. You don't see it at the micro. It's not represented there, not in relativity, not in waves. That's an error, I think. I think that's where we're missing some of this information. Somebody suggested earlier about light being intertwined circles at 90-degree angles. That's using phi forms the golden spiral. So we're excluding, with keeping these fields of study separate from each other. Again, light having a medium, studying more closely the behaviors and properties of the medium will allow, but this has been taken out of the textbooks through basically bribery. This is why Epstein's in the colleges and stuff. That's nothing new. They've been doing that for a long time, and they just pay the wrong answer. Okay, and they pay the wrong answer in an atheist way. So that's all this behind empty space. So it's like, again, all the applied science that we get what? We have a high, what do we have? We have a high precision and a low accuracy. So if we're at the firing range, all of our shots are together, but we're not anywhere near the right target.
Pythagorean theorem is actually wrong, and it disproves flat Earth. A theorem is more than a theory. A theory is a working framework to explain observations. Relativity is a theory. Gravity is a theory. But Pythagorean's equation, a squared plus b squared equals c squared, for a right-angled triangle is said to be proven fact. But it's not. Let's talk about it. When you get down to the most fundamental level, a 1x1 triangle, and you go to measure the hypotenuse, you will never measure a number that will equal 1 squared plus 1 squared. The square root of 2 is broken. It's an irrational number. It's something we know. All math gets you to 1.9 repeating infinitely, which means it's a number that will forever approach 2, but never equal 2. Therefore, your two sides of the equation are not equal to each other. What does this mean? Why is this important? Because when you get down to the most fundamental, basic levels of reality, it's nonlinear. It's not straight. It can't be flat. It's a curved line. So numbers are linear. Reality is nonlinear. What do numbers represent? Numbers are values which represent quantities. Quantities are real. Values are not. Values are imaginary things we play with to try to figure out quantities which are real. I can tell you I have a pen, but that pen's a symbol for the ink, for the structure, for this, which is really a symbol for the chemicals and for the atoms and the particles, right? But we don't know at the most fundamental level what all these things come down to. And the square root of 2 being irrational tells us reality, nonlinear. Therefore, it's not get rid of Pythagorean theorem. It's just take that to the next level and go, okay, At the most basic, we're curved, toroidal. And then from there, we can guess and we can fabricate straight lines in order to better understand reality. Also, pi is a coefficient to relate the volume of a sphere to a volume of a cube, nonlinear to linear. It is an indefinite integral, therefore, literally is infinite. Any attempts to solve pi as a finite number are inherently flawed from the jump. There is no end. Literally, it is a number that will go on forever. Our language lacks the necessary depth of categorization to accurately have this conversation, but let's reframe Big Bang and single cell evolution with a spiritual twist. Before the Big Bang, before the sun, the moon, the stars, the sky, the firmament, what was there before all of that? Before the word comes the idea. Before you can speak something, you have to think it. So our creator thought of matter, and matter took on a life of its own and has been spiraling ever since. And there's some good, there's some bad. It really depends. Relative definitions. God is hands off. It doesn't work like that. You can't just reach down to your cells just like you are creating them. And the earth comes from the sun. It doesn't just spontaneously form as in our current model. Planets are star seeds. We are children of the earth and grandchildren of the sun. We consume both. Why? What's the purpose? Well, to continue our life. And how are we going to continue our life when we know our planet's dying, our sun's dying? They have finite lives and finite resources. Well, we want to colonize other planets. We want to take their resources and use them for us as an extension of the earth. Well, it would make sense that other planets and other entities would want to do the same. So we need to look around today and go, ooh, maybe there is a little bit more going on. Maybe we need to think about what humanity's doing altogether, because it seems clear there's an invader. That's where I think the Psilocybe are products of the earth and Amanita are foreign products. And they have different accesses to different consciousnesses. That's why you see ayahuasca associated with jaguars in jungles, because the hallucinogenics enabled the contact with that collective conscious. The human could think like the jaguar and outsmart the jaguar, maybe even make peace within the collectives to come to agreements. But we're missing so much. Galaxies have their own consciousness, solar systems, stars, planets, all of them, individuals within them, all have their own. And there's a balance. But the balance can be healthy competition. It can be playing a game and high-fiving at the end and growing together. Or it can be dog eat dog. It can be cannibalism. It can be war. And the lesson that we keep getting taught the hard way is stop picking war. This is why the search for alien life cracks me up just as much as the question of belief. The question isn't if, it's what. There's life everywhere. We're staring right at it, and we just don't realize it because we have bad definitions of what these terms represent. Because evolution is based on the collective thought within the consciousness of that species and up in levels from there. So as the thought of the collective changes, so too will the evolution of that species. When you eat the mushroom, it completes, you're eating the entire cycle. You have plants go into animals, go into other animals, die, get eaten by the fungus. Everything gets eaten by the fungus. That is what returns to the underworld. The mushroom is the guardian of the underworld, the fruiting body that comes up from the mycelium that connects everything, the interweb that connects everything. And we see fungus is intelligence. When we were coming out of the trees and were whatever we were, this sacred cow delivered us the key to the universe, which is the mushroom. Christianity is based in ancient mushroom cults. John Marco Allegro was right, just not deep enough. There's so many more layers, because to climb up in intelligence, to climb up the food chain, you need to be able to think like the one that eats you. That's what the psilocybin mushrooms allowed us to do. But again, it's so much more. We jumped up from being prey to predator with that help, with that tool. And where do we get that tool from? Evolution and intelligent design, stoned ape theory and higher dimensional intervention, God and science. When you know something well, you know when to use it. When you know it really well, you know when not to use it. My body is constantly emitting photons through natural biological processes. Could I ever be an observer of the photon that I emit? can the emitter of the photon ever be an observer of that photon? No, you would have to break the fundamental underlying law that develops that theory and travel faster than light to get in front of it and then catch it. But you couldn't do that. So why would your movement relative to the observer be taken? It's all to add a bunch of nonsensical logic on top of a wave through space, a ripple in the ether. Space-time is nonsense. It's a virtual, it's a mapping, it's a coordinate system. It's not nothing, but it's not real. Like, we've literally gone around and said that the universe is not real. Things aren't real. It's like, what are you talking about? Like, that's should be principle number one. Like, number one, things are real. Number two, where do we go from there? Like, why would we assume the opposite?